Welcome to Aurora Chemistry for everyone. In this video, we will see polarity of geometrical isomers. Polarity can be predicted from dipole moment, which is the product of charge and distance of separation. This is shown by crossed arrowhead. The cross should be near less electronegative atom and that arrowhead should be more electronegative atom. If you see our cis-butene and trans-butene, these both are isomers. We will discuss among these two which one is polar. So to know that, first let us find that dipole moment. So this dipole moment can be predicted by drawing that individual dipole. So individual dipole we go to draw. So if you see that in cis-butene, these both two CH3 groups are in the same side, but in trans they are in the opposite side. So among these, which one is having that higher electronegative element? See here, this carbon is attached to double bond. So this makes that carbon into more electron dense atom. So due to this double bond, this both carbon is getting partial negative charge. So this carbon is getting now partial positive charge. So the same thing happened for trans also. So these two carbon attached with the double bond is partial negative and then CH3 group carbon partial positive. So from this we can draw that individual bond dipole. So now we know that this one is highly electronegative part. So that arrowhead should be this carbon and the cross should be that CH3 group. The same way here also that arrowhead should be this part and then cross should be here. Now come to trans-butene. So trans-butene, for this CH3 group, individual dipole we can draw by the cross should be this side, then arrowhead should be the carbon attached to double bond. The same way here you can see this part is more electronegative part. So while drawing, arrowhead should be this carbon attached to double bond, then this CH3 carbon will get crossed one. For polyatomic molecule, the sum of individual dipole gives that dipole moment. So now we go to add this. Here you can see that individual dipole both are in the same direction. So both are in the same direction. So that results in some amount of dipole moment. It is estimated that 0.22 d pi for cis-butene. Now come to trans-butene. They are in the opposite direction. So one on this side, then another one is on pointing upwards is nature. So when you add, what will happen to this? This both will cancel each other. So they cancel each other since they are in opposite direction. That result in zero dipole moment. So if dipole moment is zero, then no net polarity. That means this compound is non-polar. So, but what about the cis form? This one is having 0.22 d5. So this compound is polar. So among cis-butene and trans-butene, cis-butene is polar molecule. Thanks for watching.